In this video, I would like to compare numbers in a variety of bases at the same time. I want to make some equivalency statements. So in this example, I'm comparing base 2, base 4, base 8, and base 10. What would a number look like in base 2 that's equivalent to a number in base 4 that is equivalent to a number in base 8 that is equivalent to a number in base 10? In other words, it has the same value in every base. And we want to start with a relatively small number so we can kind of see how that works in a variety of methods. So let's take a look at the number. Let me write this down. 1, 1, 1, base 2. 1, 1, 1, base 2. Well, what is that equivalent to in base 4? What is that equivalent to in base 8? What is that equivalent to in base 10? So how could we find this value? Well, the problem is we're not familiar with base 2, 4, and 8 very much. We're just getting started. The one we're only really familiar with is base 10, our regular system. So what I recommend is first taking this number 111 base 2 and seeing what its value is in base 10, and then we can come back to the other bases. So I'm going to zoom here and on base 2 so we can take a look at it. You know, remember in base 2 we can label the place values: 1's place, 2's place, 4's place. So the code 111 has a value of 4 plus 2 plus 1. There's one dot in each. Well, that adds up to 7. So that means our number 111 base 2 is equivalent to 7 in base 10. I don't feel the need to ever draw a base 10 box, so I want to just make a comment on that. There's no need to ever draw a base 10 box because we're very familiar with base 10 already. If we're given a number in base 10, we just should know what the value means. But it can be useful in bases 4 and 8. But now what I want to do, instead of thinking the value of 111 base 2, because I don't really know how much that is. In fact, I want to show you something funny. If I said, show me 111 base 2 fingers, you should show me this many. You should show me what we normally call 7. So what would that be in base 4 or base 8? Well, what we're trying to do is build a value of 7. In base 4, we have the 1's place, the 4's place, the 16's place, and so on, each time multiplying by 4. Well, I'm only trying to go up to 7. So what would be required is a 4 and 3 1's. 4 plus 3 more would give me 7. And that would be the code of 1 dot, 3 dots, or 1, 3 in base 4. So I would say, okay, that number is 1, 3 base 4. And then lastly, again, I'm not trying to convert from base 4 to base 8. I'm just trying to make an equivalency statement. I always want to think about base 10. It's really a value of 7. In base 8, I have the 1's place, the 8's place, the 64's place. I'm not even allowed to put a dot in the second box because that's already a value of 8. So actually, I would just use 7 1's, 1, 2, 3, 4, 5, 6, 7. And so strangely enough, as strange as it may seem, the code for 7 in base 8 is actually 7. I hope that makes some sense. And I know it will if you meditate on it.